Let's solve equations with fractions. So if we quickly recall, we have x over 2 is equal to 7. We find the opposite operation and we perform on both sides. In this case, the opposite operation of division is multiplication. Multiply both sides, left and right, by a factor of 2. We isolate our variable x, and 7 times 2 give us 14. And then on our recall, for example, b here, n divided by -3. The opposite operation is multiplication by -3. Do that to both sides. I have the n isolated, and my value for n is -12. So when we are solving equations involving one fraction, there are actually two methods that we can use. I'm going to go through both, and then moving on, I'm only going to be using one method. So the first method here, I rewrote it, 6 is equal to 1 over 3 multiplied by 8 plus x. We can go ahead and use the distributive property and distribute 1/3 into the bracket. So 1/3 times 8, 1/3 times x. Now as I rewrite it, 1/3 times 8 over 1 plus 1/3 times x over 1, right? Because whole numbers can be written as over 1. I'm also going to change the left side to a fraction to represent 6 over 1 as a whole, because we're going to be manipulating that a little bit later. When I perform 1/3 times 8 over 1, I end up with 8 over 3, and when I perform 1/3 times x over 1, I end up with x over 3. Now, I have 8 over 3 plus x over 3. I'm going to anticipate that I'm going to be adding and subtracting fractions. I'm going to change the denominator on the left side here to 3, and how I do that is I multiply by 3, so that 6 would then become 18. So now I have 18 over 3 is equal to 8 over 3 plus x over 3. All of the denominators are the same. Now I can go ahead and add or subtract fractions. In this case, how do I isolate my variable x? Well, x over 3, I'm adding 8 over 3 to it, so I need to subtract that. So when I pull that over, I have 18 over 3 minus 8 over 3. So this is positive 8 over 3. It then becomes negative 8 over 3, or minus 8 over 3. That is all equal to x over 3. Continuing on, 18 minus 8 is 10 over 3, and that is equal to x over 3. Now how do I solve for x? Well, I need to isolate it by multiplying by a factor of 3. So I multiply the right side by 3, I multiply the left side by 3. It just so happens that both the 3's cancel out, and I'm left with a value of 10x. The other way we can do it is I go ahead and I write my fraction 1 multiplied by 8 plus x, all divided by 3. If you remember that from a few videos ago, that is how we went to go ahead and solving some equations regarding fractions. So then I go ahead and distribute that 1. Actually, no, pardon me, before I do that, I need to get rid of this denominator. So in order to do that, I need to multiply the entire right side by 3, right? Because this whole thing is being divided by 3, opposite operation, multiply by 3. So if I multiply the right side by 3, I must multiply the left side by 3, right? This is the whole balancing thing we were talking about, right? What you do to one side, you have to do to the other in order for the equation to remain balanced. Once you multiply 3 on the right side, that becomes eliminated, so now you're left with 8 plus x is equal to 18, and then we can go ahead and solve for x, in which case we get the same answer as method 1, which would be 10 is equal to x. So our second example here, we need to solve 3 times y minus 5 over 4 is equal to 9. So on my left side here, this whole side is being divided by 4. Well, I need to get rid of that divided by 4, and how I do that is I multiply by 4. So then those cancel. What I do to one side, I must do to the other. So when these 4's cancel, and 9 multiplied by 4 is 36, and I'm left with, on the left side, 3 times y minus 5. Then I go ahead and use my distributive property. I distribute 3 into the bracket, becomes 3y minus 15 is equal to 36, and I continue to solve for y. 3y is equal to 51, 36 plus 15. 3y is equal to 51, divide by 3, I end up getting my y value of 17. Solving this, 2 is equal to 1 over 8 times s plus 7. So again, rewriting it as s plus 7 over 8, I need to get rid of this denominator, so I multiply the right side by a factor of 8. What I do to one side, I must do to the other. So 8 times 2 would then be 16, and now that denominator is eliminated. So I'm left with s plus 7. And then I just go ahead and solve for s. By bringing that 7 over, it becomes negative, and I'm left with an s value of 9. When we're solving equations with more than one fraction, as I've written out here, I have k plus 2 over 3 is equal to k minus 4 over 5. Now, what I need to do is I need to get rid of this denominator. And how do I do that? Well, I multiply it by a factor of 3 in order to cancel out, and I've written that here. So if I multiply this by 3, we know that we need to do the other side by 3 as well. So that would in effect cancel out the denominator here. But I also have a fraction on this side of the equation, right? I have k minus 4 over 5. So I need to eliminate this denominator as well. And how do I do that? Well, I multiply the right side by a factor of 5, which I've done here. But what I do to one side, I have to do to the other. So that's why I've written the 5 over here. So on the right side, these 5's cancel out, and I'm left with a remaining equation. So now I'm left with, this is 5 multiplied by k plus 2 is equal to 5 multiplied by k minus 4. Pardon me, that's a 3. Just kidding. 3 multiplied by k minus 4, right? So we keep this 3 multiplied by k minus 4, and we keep this 5 multiplied by k minus 2. Then I just simply go ahead and use my distributive property. 5k plus 10 is equal to 3k minus 12. Then I have 5k minus 3k. I'm collecting my variables on one side. And then I have negative 12 minus 10. And then I'm going to end up getting, zoom out a bit, 2k is equal to, well, negative 12 minus 10 gives me negative 22. I then divide both sides by 2 to isolate for k. K is in a value of negative 11. So another equation that we have down here, two fractions, one on either side of the equal sign. So again, I have 3x plus 2 divided by 8 is equal to 3x minus 2 divided by 4. I need to eliminate the divided by 8 on the left side, so I multiply it by 8 on the left side, but I also have to do it on the other. Similarly to the right side, I must multiply by 4 in order to eliminate this, but what I do to one side, I have to do to the other. So again, I've effectively canceled out by multiplying that and dividing that. I've canceled that out, multiplying that and dividing that. I've canceled that out as well. So now I'm left with 4 times 3x plus 2 is equal to 3x minus 2 times 8, right? Because these have all been canceled out. And then I simply go ahead, distribute into the brackets. I end up getting 12x plus 8, and distributing 8 into the brackets, I get 24x minus 16. Then I simply go ahead and continue to solve for my variable by bringing all of my variable terms onto one side, constant terms on the other, and then solving for the variable by identifying the opposite operation needed to isolate the variable, in which this case, it ends up being x is equal to 2. Example C, I have 1/6 multiplied by z minus 4 is equal to 1/2 multiplied by z minus 2. I just rewrote it because I like seeing things as a fraction as opposed to a fraction multiplied into something. So if I have rewrite it as z minus 4 over 6 is equal to z minus 2 over 2, I know I need to multiply the left side here by 6 and the right side, and I need to multiply the right side by 2 and the left side by 2. So I'm left with 2, because these 6's would cancel out, 2 times z minus 4 is equal to 6 times z minus 2. Distribute in, I get 2z minus 8 is equal to 6z minus 12. Solving for my variable, brought all my variable terms on one side, constants on the other, and I simply go ahead and solve for z, which in this case would be equal to 1. So when we're talking about the distributive property, or solving equations, with fractions, I find it very helpful to rewrite the fractions if we can in order to identify, okay, what do I need to do to cancel this fraction? What do I need to do to cancel that fraction? And we have to do it on both sides of the equation in order for everything to remain balanced.